In the old days, like 20 years ago, if you wanted a computer to do something, you had to be a micromanager. Imagine trying to teach a stickman how to identify a cat. You'd write a massive book of rules. If it has pointy ears, it might be a cat. If it has whiskers, the probability increases. If it is sitting on a laptop while you're trying to work, it is definitely a cat. This worked for simple stuff like calculators or digital clocks, but for the big, messy world, it was a disaster. The moment the stickman saw a dog with pointy ears or a very hairy human, the whole system crashed. Humans are great at knowing what a cat is, but we are surprisingly terrible at explaining why we know. So we gave up on writing rules. Instead, we started building the warehouse. Imagine a warehouse filled with 1,000 tiny, empty-headed student bots. None of them know what a cat is. In fact, most of them don't even know what eyes are. To get a smart bot, we don't teach. We iterate. We use a builder bot and a teacher bot. The random phase. The builder bot wires up the students' brains almost at random. Some bots think cats are round. Some think they are purple. Some just scream digitally. The test. The teacher bot shows them a million photos. The students guess. Most of them fail miserably. The selection phase. The teacher bot doesn't give feedback. It just looks at the grades. The bottom 99% are, well, they go to the recycling bin. The mutation phase. The builder bot takes the 1% who were slightly less terrible and makes copies of them, but with tiny random changes. Repeat this a million times. Eventually, through pure digital evolution, you get a student who can spot a cat in a dark room, wearing a hat, behind a curtain. You might have noticed those "Are you a robot?" tests while trying to buy concert tickets. When you click on the squares with the crosswalks, you aren't just proving you have a pulse. You are writing the answer key for the teacher bot. AI is a data eater. The longer the test, the smarter the bot. More photos, better at seeing, more transactions, better at spotting credit card fraud, more hours of you watching videos, better at knowing exactly which weird 3 a.m. documentary will keep you glued to your screen. If it can be measured, it can be taught. Here's the part that makes computer scientists a little nervous. We don't actually know how the winner does it. The winning bot's brain is a giant tangled mess of millions of digital connections. We can see the wires, but we can't read the thoughts. It's like looking at a single grain of sand to understand a beach. You can understand the grain, but the beach is too big to hold in your head at once. The bot might be looking at the cat's ears, or it might have realized that cat photos usually have a specific type of blurry background. If you show it a cat in a different setting, it might totally blank out. It's brilliant, but it's also a bit of an idiot savant. We are now surrounded by these accidental geniuses. They decide what news you read, what price you pay for an airline seat, which of your friends' posts show up in your feed. We didn't build these bots to be logical. We built them to survive the test. And as long as they keep passing the test we give them, they get to stay. We are using tools that no one, not even the people who made them, fully understands. It's a bit strange, a little funny, and definitely a lot of linear algebra, but hey, at least the bots are getting really good at finding the cats. Remember, the bots are watching us.